All right, welcome back, everybody. Um, so this is a question that I took a look at yesterday. So today is July 16th. I looked at this question yesterday on the 15th and was struggling with it, but I found the solution really, really cool. So I've taken about maybe a day or two, I can't remember if it was yesterday or the day before, away from it, and I'm back now. I haven't looked at the solution, so I'm attempting it again, kind of with a bit better intuition of how I should go about this because of reading the solution a couple of days ago. But I also don't fully know how things are going to go here, so we will see if there are cuts in the video. It was just me thinking, but I'm gonna do my best here. All right, so you are taking candies one by one from a jar that has 10 red candies. So there's 10 red, 20 blue candies. Okay. There's 20 blue and 30 green candies in it. 30 green candies. What is the probability that there are at least one blue candy and one green candy left in the jar when you have taken out all the red candy? So at least one blue and one green left in the jar when you've taken out all the red candies. So that basically means there's one or more blue um, and one or more green by the time we finish taking out all the red candies. And so taking out the red candies, basically, if we were just working this out, if we, for example, were in a scenario where we picked out all the red candies first, probability of that would be, um, probability of that would be, let's see here, we have, it would be, one, or no, I'm sorry, it'd be 10 over 60 times, 9 over 59, and so on. And that's the probability of picking out 10 red candies in a row, but that's not really what we're looking for, I don't think. One green candy left in the jar when you have taken out all the red candies. So, okay. So I think I'm supposed to do something like this. It's like the last candy I can pick out of the jar can either be red, and so we'll call that T sub R, or the last candy I pick out of the jar can be blue, which we'll call T sub B, or the last candy I pick out of the jar can be green, which I will call um, T sub G. And I know that there's a 10 over 60 chance that the last candy will be red. There is a 20 over 60 chance that the last candy will be blue, and there's a 30 over 60 chance that the last candy will be green. And the reason that this makes sense is because if we can kind of think about it symmetrically here, if we, when we pick out a candy randomly and we put it down and we say, this is the first candy I picked out, right? And then we pick out another and another and another. It's the same as also picking out that candy and saying, hey, this is actually gonna be the last candy I picked out. This is gonna be the second to last. This is gonna be the second to, or third to last. This is gonna be the fourth to last, and going that way. And you see that these two ways are the same. So in the way that the first candy picked being red is 10 over 60, the last candy picked being red is also 10 over 60. And so we have a nice little use of symmetry there to go off of that. Okay, so what else does this tell me? So if this is the event, the last candy picked is red, we don't want this event. Like, this is the last possible thing we want because, um, hmm. Okay, wait, no, I think it's like this. Let's call this picking the last red. right? Picking the last red. Let's call this picking the last blue, and let's call this picking the last green. Okay, so I'm gonna forget about these probabilities real quick. So there's a couple there's basically two scenarios that I can want, right? I basically either want I pick the last red, um, basically on a pick that's less than picking the last blue, on a pick that's less than picking the last green, right? That's one of the things that I'm looking for. Or what I'm also looking for, and these are mutually exclusive, they cannot happen at the same time. I'm also looking for the probability I pick the last red, on a pick that is less than picking the last green, on a pick that is less than picking the last blue. Let's think about this now. Um, okay, so picking the last red less before the last blue here. If there are 30 in total, I have a 10, right? Do I have a 10 and 30 chance? Okay, okay. Hmm. Hmm. I think it's gonna be like this. So I think, hmm, 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 hmm. Yeah, I'm gonna have to stop here for a second and look at the solution, I think, because now I'm getting confused again. Okay, so I'm back and I understand what I'm looking for now. Basically, what I'm looking for um, is a way to use conditional probability. And what we're going to use here is basically we're going to use this identity that, the probability of A and B is equal to the probability of A given B times the probability of B. And this is going to be fundamental for our approach here. So let's just start with this first scenario here, right? So I start with the first scenario here. What am I looking for? I'm looking for the probability that the pick of the last red is less than the pick of the last blue, right? Um, it's less than the pick of the last blue, and I'm also looking for the fact that that the 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 pick of the last green is the last pick, right? So basically, the pick of the last green is the last pick. Okay, that's basically what this is here, and so this is equal to right. We're going to use our identity. Basically, what is the probability first of this that the last red selected is a selection less than the last blue selected, given the green is the last pick. Okay, so if we know green is the last pick, then basically what we're dealing with here is a sample space of the reds and the blues, which is 30, right? So what is the probability then that the blue is the last blue ball is picked after the last red ball? It's a 20 over 30 chance because all balls have equal probability of being that last ball picked, right, in the sample space, and there's 20 blue balls. So this is a 20 over 30 chance right here. Just this part given this green is the last pick. So then what is the probability that green is the last pick? The probability that green is the last pick we can find in the exact same way, right? There are 60 balls total, and all of them are equally likely to be this last pick, okay? And there are 30 green. So in this way, this is the probability that we choose the last red on a on a selection before the last blue, on a selection before the last green. Okay, and we'll see, this crosses out to be 1/3, right? So the probability of that is 1/3. So now, okay, let's look at the next part here. What's the probability we select a red, the last red, before the last green, before the last blue? And again, we can kind of relate this to our other forms, right? It's basically we're looking for selecting the last red before the last green and selecting blue last, right? So selecting blue last, that's basically what we're saying. And as I just went over earlier, that's just equal to, the probability we select red, the last red, before the last green, given we select blue last, right? So if we select blue last, then we know we're only dealing with this sample space of reds and greens, which is 40, right? The sample space here is now 40. Oh, and of course, I'm sorry, this is times the probability of selecting that blue last. Okay, because of Bayes, right? So starting with this part on the left, right? So selecting the last red before the last green, given we selected a blue ball last. So then we know we're only dealing with the sample space of red and green balls, right? Which is a sample space of 40. And all of them have an equally likely chance to be the last one picked, right? Between these two. And so the chances that you select the green one last are then going to be 30 over 40, right? Because there's 30 green balls and there's only 10 red. And then we multiply as we do here, right? And what's the probability we select a blue ball last? Well, there's 60 balls and 20 of them are blue, and they all balls, have equally likely chance of being that last one selected. So obviously the probability is 20 over 60, right? So 30 goes in here once, goes in here twice, right? Twice, once, and we have this is equal to 1/4. So now we have 1/3 plus 1/4, right? And this is going to basically be 7/12, right? All right, awesome. So I thought that was an interesting one. Really unintuitive approach, I would say, to, basically the event that we're following is the pick, the selection that is the last selection of each color, right? Very weird, unintuitive, but it is really clean and cleans the problem up quite nicely. So yeah, the probability that at least one blue and one green candy left in the jar when you have taken out all the reds is 7/12. So a little more than 50%. Thanks for watching.